Hello students, good morning to all. I hope you all are fine. As you know that we were already discussing about the method of preparation of aldehyde only. Students, these are the methods which are used only for the preparation of the aldehyde. Rosenman reaction, Stephan reduction, Etard reaction and side chain chlorination followed by the hydrolysis. And last one method that is used for preparation of aldehyde only, that is gattermann-koch reaction. We have already discussed these three reactions, Rosenman, Stephan and Etard. So today we will discuss about these two reactions. Okay, so first of all we will discuss side chain chlorination followed by the hydrolysis. Students, if we have toluene C6H5CH3, its IUPAC name is methyl benzene, but its common name is toluene. If we do chlorination of this in presence of the sunlight, you know very well because we have done in haloalkane, they will follow the mechanism of the free radical. They will follow free radical mechanism. So by free radical mechanism, here one hydrogen will replaced by the halogen. Here one hydrogen, three hydrogens are there. So one hydrogen will replace by this chlorine. Plus removal of HCl take place. One hydrogen from here and chlorine from here. Then students, you know very well this reaction gives mixture of the compound, mixture of the product. So further chlorination takes. Okay, so after formation of the benzyl chloride, students, we will do the hydrolysis of this. Means we will react with the water. Okay. Then directly we will get our desired product, and that is the benzaldehyde. That is the benzaldehyde. So this preparation, this method of preparation is used for the preparation of the aromatic aldehyde. Here, student, directly we can do. We will give one oxygen to this one and two hydrogen to this one. So from here, removal of two hydrogen chloride take place. Okay, and we will get our desired product, that is the benzaldehyde. So this method is known as the side chain chlorination followed by the hydrolysis. Okay, now we will discuss last method of preparation of aldehyde only, that is gattermann-koch reaction. Students, this is the naming reaction. It is very important for our board exam, and sometime you will get this reaction by name only in your exam. Okay, so what is the gattermann-koch reaction? Gattermann-koch reaction is that when benzene ring is treated with carbon monoxide and hydrogen chloride in presence of anhydrous AlCl3, aluminium chloride, or we can say cuprous chloride also we can take. Okay, students, here also we will get the aromatic aldehyde, that is benzaldehyde. That is benzaldehyde. So which mechanism will be followed by this reaction? Now we will discuss about this. Now see the mechanism. Students, this is the reaction. Benzene ring treat with carbon monoxide and hydrogen chloride in presence of anhydrous aluminium chloride, or we can take cuprous chloride also. Then it will give as benzaldehyde. Okay. So, how this reaction can take place? What is the mechanism of this reaction? We will see that. Here, students, we have carbon monoxide. You know very well what is the structure of the carbon monoxide. Here, carbon has 4 electrons in its outermost shell, and oxygen has 6 electrons in outermost shell. So here oxygen can share 2 electrons and it can form 2 bonds. But students, see here 2, 4, 6 and 8 means oxygen is stable here. But till carbon has 2, 4 and 6. 6 electrons only in its outermost shell. So it is not stable still. So students, we will see we will form 3 bonds. We will form 3 bonds here. So how does it can form the third bond? Here, this electron pair is shared by oxygen. Coordinate bond will form, okay, between oxygen and carbon, because here one side sharing is taking place. Only oxygen is giving it electron to the carbon. Okay, students. So we can write the structure in this way. Carbon is gaining the electron, so positive charge will attain on this one. And here oxygen is losing the electron, so negative charge will attain on this. So students, this will be the final structure for the carbon monoxide. Okay. So here we can write the structure in this way. We are doing the reaction in presence of the HCl, in presence of HCl, hydrochloric acid. So here, sorry students, here oxygen is giving the electron, na? So positive charge will come on the oxygen and carbon is taking the electron. So negative charge will goes on the carbon. Okay, so this is the structure of the carbon monoxide. So here positive charge is on the more electronegative element and negative charge on more electropositive element. Okay, so which make it unstable. Then what will happen, students? Because we were taking the presence of the hydrochloric acid, so here this carbon will promote this hydrogen. Okay, because here in case of the hydrogen chloride, chlorine is the more electronegative. So it has tendency to share shared pair of the electron towards itself. So student, it will take the electron from this bond, and from here proton can be donated by this one. So here it is in form of the H positive. So this H positive will attach to this carbon monoxide, means it will attach to this carbon. Then student, you will get carbon, here attachment of hydrogen take place, here attachment of hydrogen take place. Okay, and removal of Cl negative will take place from here. Now student, you can see again there is positive charge on this oxygen, which is making it unstable because it is more electronegative. After that positive charge is on this one. Then students, it can take the electron from this pi bond. After taking the electron, because it is taking electron from carbon also, so positive charge will attain on this carbon, and here it will take electron. Already positive charge is on this, so it will be the neutral. So you will get the species in this way, students. Then the chloride ion, which was eliminated from here, it will support this carbon because there is positive charge on this carbon. Then here positive and negative, by electrostatic force of attraction, they will form the bond. Okay, and finally we will get this species. This is the formaldehyde ion, we can say this one. Okay, so we will get in this way. Now students, after formation of this intermediate, We were also taking the presence of the aluminium chloride. And you know very well aluminium chloride is Lewis acid because after formation of the bond, its octet is not completed. Its octet is not completed. So here AlCl3. After formation of bond, it has only 6 electrons in its outermost shell. But for getting stability, there should be 8 electrons. Okay, so it has tendency to gain some more electrons. From where it can take the electron. So we will see about the availability. So where electrons are available, you can see here chlorine. There are 6 electrons available at this chlorine. Okay, students. So here this chlorine can donate the electron to this aluminium. Okay. Then from here, these 2 electrons, they will shifted here. They will make a bond, and then this chloride ion can be eliminated from here. Then AlCl3 plus chloride ion. Then they will form the AlCl4 negative. Now it is stable because its octet is completed now. Okay. Then removal of AlCl4 negative take place, and from here, because this pair of electron is shifting here, so here already 2 bonds, so it will make one more bond also. Now there are 3 bonds. It is forming triple bond, and this carbon is forming one bond with this hydrogen. So this species we will get. Okay. Now because here this oxygen is losing their electron, so positive charge will attain on this. Again it is forming it unstable, so it will take further these electrons, and we will get positive charge on carbon because it is losing its electron. Okay, so we will get finally this species, and student, it is known as the formyl chloride. It is known as the formyl chloride. Now this is the reactive species, and it will initiate the reaction. Okay, now it will attack on the substrate. What is the substrate we have? Here we have benzene. We have benzene. Okay, so what will happen? Here you can see pi bonds availability in benzene ring. Due to availability of the pi electrons, here positive charge is on carbon, so this pi bond can support this carbon. Okay, it can support this one. So from here this bond will shift again at the oxygen, so which is making stable to this species. Okay, now students, because this carbon, it is supporting to this one, so it is losing the electron. Now positive charge, because it is removing the electron, it is releasing the electron, so positive charge will goes on this carbon. Okay, now this bond is breaking, and it is forming bond with this carbon. Okay, so it is forming bond, and this carbon is forming bond with the oxygen and one hydrogen. Now students, you know very well, in structure of benzene, at every corner one carbon is present and one hydrogen is also present here. One hydrogen is also present here. Okay, because formula of benzene is C6H6. Formula of benzene is C6H6. And you can see also carbon is tetracovalent, and here carbon is forming one bond with this hydrogen, one bond with other carbon, and this is double bond. So 1, 2, 3, and one bond with this carbon. So its valency is completed now, means it is having one hydrogen at each carbon. So students, one hydrogen is also present here. I am not taking this hydrogen from outside. Availability of this hydrogen is already in benzene ring. Now students, you can see this hydrogen, it will break the bond. It will break the bond and from here we will get H positive, and this bond will shifted here. So further we will get double bond here. Okay, and finally we will get our desired product, and from here removal of H positive take place. So from here you can see, students, at starting reaction was initiated from H positive, and finally we are getting H positive, means it is just proceeding the reaction, it is just increasing the rate of the reaction, but it is not consuming in the reaction. Means here acid is behaving like the catalyst. Acid is he is behaving like the catalyst, because it is increasing the rate of reaction only, but it is not consuming, it is not involving in the reaction. So here acid is the catalyst. Okay, students, so this is the mechanism followed by the reaction. And students, which mechanism is followed here? This mechanism is electrophilic substitution. Why it is electrophilic substitution? Because here hydrogen was present at the carbon, and we are replacing this hydrogen by the CHO group, because here we are replacing one electrophile by other electrophile. So this is known as the electrophilic substitution reaction. So students, this is the reaction when benzene react with the carbon monoxide and hydrogen chloride in presence of the anhydrous aluminium chloride and cuprous chloride. We can take presence of one, either aluminium chloride or cuprous chloride, then we will get benzaldehyde. So this reaction is known as the Gattermann-Koch reaction. Gattermann-Koch reaction. So students, I hope this mechanism is clear to you. So today we have completed method of preparation for aldehyde only, and tomorrow we will discuss about method of preparation of the ketones. Okay, so thank you. Have a nice day.